Hello, welcome to Raw Hacking video, and today I'm gonna implement methods to my programming language, and let's see what I already have here. So this is what this language looks like. There are structs, basic structs, and functions. And here we have arrays, and no, that's actually a hack so that for default initialization, in the future I will just, it will work like something like that. Like in Rust, you need to initialize all variables manually, so your mom would be something like that. But for now, I have a hack which allows me to like default initialize so that I don't need to implement this inline structs operator, but expression. But yeah, today I will implement struct methods, and I have seen two ways to declare methods. So let's add a new test, like methods.esr. Like this is S line. That's the name. That's after my framework, which I want to port to this language eventually. So I have okay. Let's define a struct. I think let's name it foo, as everyone does, and then we have a func main. So let's define a variable, and we have like in my language variables are immutable by default. That like in Rust, because immutability is nice. Like, if you have several hundred line of function, or like if you have long functions, you don't need to I had some code in Python here that was even this test runner, which I have this test path and I needed to search for um, it has, I think it has some very weird value, and in if something is in variables are immutable by default, it would be like you know that the variable won't change, and here in Python or like dynamic programming languages, basically everything can change at any time. So that's it's sometimes annoying, but let's go back. Okay, so you have a foo, which is a default initialized foo. Yes, semicolons are required, and let's run some method on it bar. So like nothing special. We have a dot, and currently it wouldn't compile. So we go to, and yes, we need bootstrap ASL test struct methods. So this wouldn't compile, it would like shout at me that that it expects a semicolon, which is which is actually a bug, and like parser should accept that. But that would be I think we need to fix now it today actually. It's otherwise we wouldn't be able to parse methods. This should fail in type checker. That bar is not callable or something like that. Okay. So the first thing is fixing this parser, and I think that's basically because we are if we parse function, no, that's we are parsing hmm. Okay, let's go to parse expression, and that's I think while parsing primary or postfix expression, then operators, like, because postfix expressions are always less uh, lesser priority. Like now they have more priority, so like you never have something like a times b like plus plus, and this plus plus is like always has just b as a operand, not the whole x, not the whole a times b. Postfixes are always bigger variety of operands. So yeah, I'm here parsing a primary expression, and then I think functions are currently primary expressions. So like you have here brace open, so like arrays are done properly. So we can do multi-dimensional arrays like this, and that works. But functions I just haven't ported it to the new to this function. So yeah, even if you go to the primary expression, we have a parent open. Like no, that's parent size expression. So that's parents. Yeah. So that's these ones, and then we numbers, literals, keywords, and yeah, we are just hard coding these in identifier. So that's not okay. If we ever get to the primary expression, we'll just parse return a identifier. So a parsed identifier. So ID would be a token value, and we have to give a range, which would be actually, let's see. Okay, that's this thing. So this is one of the usability issues that I would want to fix at some point, because like currently, if you want to have a range for last several tokens, you need to do like range offset -1 -n and size n. And it would be nice if we could do like a range for last or something like that. And last tokens, like it could have a better name, but something like that. Like range for the last token. I would want to get. But okay, so then we have the ID, which is something like that, and then that would be simple actually. I would want to. Okay, so in this while loop, that would be just another else case, like another case. So if we get a parent open, we parse the expression list. So so we get our parse call arguments for ID, and well, okay, that's unexpected a bit. Oh, okay, I think there's a fix me for this. Okay. This should be an expression, yeah. This should be an expression. That's what we need to do now. So, otherwise methods won't work at all if we didn't do that. So, that would be. So what's yeah. So we get a parse expression called like actually so callable, and then it would we won't ever parse all arguments. That doesn't make sense at all. So we remove this thing, and then we get we can actually move this thing here. So then we get something like parent open, expression list, parent close, and yeah, something like that. So get the first parent, then start the expression list with end token, which is parent close. Like it's when it's parsing these expressions, it just returns from this function when it gets a end token. So like normally we wouldn't know that that it's already the end of the like it could be anything. This end of the expression, it could be like like square brackets or normal like curly brackets, but we have here normal brackets. So yeah, we have a expression list. It's basically an equivalent of a comma operator in C++. This thing. That's okay. So we have this expression list. Then we expect a closing, which is I think it's not consumed here. So we expect we can even mask this. Can type parent close. Yeah. So we expect a parent close here, which is actually implied by the fact that we are no. No. That's what if we what, what if we don't close an expression list, like exp list not closed ASL, where we are parsing the expression list. In for inline array, yeah, that's the place we are using square brackets instead of normal brackets. But ASL. What? Okay. What's going on here? Let's just copy that, and we have syntax exp is not closed. Yeah. So, but let's actually do something here. So, array is something like that, and let's check if this. I think this should crash if we have unclosed literals the last thing, because crash or okay, because it's peeking for the end. Oh no, this will fail in parse expression, I think, but let's check anyway. So yeah, now it worked. Like it got an error, but now okay. So this doesn't crash. I just need to check that. So we have this expression list, which we parse, then expect a parent clause. So we need to actually expect that. Because if expression list, it can break if there is no comma after also. That makes me wonder if we actually need, like, do we even need to check for and token? Oh yeah, because of empty list. Okay, so we have this expression list, and then yeah, we expect this parent closing, and then we assign. We basically make it in the function. So expression is parsed parse call, and this parse call is with callable, which is a exp, the old expression. Arguments are exp list, and name range is like it's callable range now, so it's this old expression basically, but now we can't. We don't have this range actually. We can leave this as a fix me, or like let's make it working. So exp start would be the current offset, like the offset at the beginning of the expression, and then we have for name range we have, like, this is the thing. No, start, and the size would be this offset minus start. So, and also was making my fun working so loud. This thing. No. What was the command? SPI, no, that was okay. Never mind. Okay, so you parse this expression list, and let's also add a test for that. So we have like x please not close. That would be one test to add today, and then we have a calling function or nested postfix expressions. Nested postfix expression. So we basically do something like something like that. And this should parse successfully. This should parse, but obviously fail in the type checker. So we compile that, and so there's some compiler here, yeah, because of the name. So we need it's printing. I think this would also file to compile in the type checker, which uses the name here. So so we'll get a well, callable print, just something like this, and then we print the opening path. Then it will fail the type checker, and that makes me like we need to like because we have no name, so we need to resolve this name to a function, and then we can like we need to introduce it a function type basically, because we can't now just resolve the call name. We need to like type check the expression which is inside. So we have a callable which is type check expression, and this expression is a callable, and then this expression needs to be a function. So normally it would fail here. So we can maybe let's add a new function type which would be very basic for now. Very basic. So we have type, struct type, I think. Yeah. That's here. So currently we have array types, primitive array, like arrays, primitives, some like bool, string, u32, and we have also structs. We have also structs, but now we'll need to have also functions. Because yeah, we need to have functions. And so this would be a function type, and a function type has function ID, like function ID, targets, some kind of target. And then we have like target or function, let's name it normally, and the name would be like it's not iterable, yeah, and then the name it's here. Okay, so the name would be would be taken from the function. No, it will be taken from the function type, but let's return a func for now. Or func or func in the function name, so that we know, like we don't have actual function types. I want to make actual function types for now. Just something so that function expressions will properly. So we get a function which is, and then a name. Okay, yeah. Let's use string format here. So, we can even make the basis so that we signify that this function cannot be written in the like it's not supported by the syntax yet. Okay, and then we for type checking, when we type check identifiers, we need to return function. This is a function. And then it would check for identifiable type is like we need to check if that's a function. So function type, callable type needs to be function. If it's not, we return an error, and that's type. Whoa, yeah. We need to get a type. from a program. And then we can do that. So, and also we need to access it to the variant. So function type. Yeah, and then like it's not callable. And then here we should like, let's just name it expression. It's not callable, so just something simple. And we have this name range which should be named differently, you know. Did it update all cases? I think yes. So yeah, returning value expression, and then the rest is simple. We get just callable func, which is this, and then we'll just get a function ID, which is also we have this hack for print, which will need to be rethinked. So if this function is, we can check it here. So if the function name is print, like the text function or the parsed function is print. So if we this expression like yields print, we skip type checking args because we just don't have enough support in the language to like just support. We can't just support like the varargs which are needed with it. So we have this, and then we need to actually implement function type checking, I think. So currently it would parse identify. So it would, yeah, it needs to refer to a variable, like not anymore, actually. So we can just switch by the result ID type here. So switch result ID type, which is a. Also, I think this will make very easy to support inline like, local functions inside other functions, like nested functions, basically. Because we'll have just this result identifier which checks like first in the scope, then in the function, and lastly in the imports. So that should be very easy then. So we have these three types of resolution, and then if it's invalid, we return an error, obviously. If it's a variable, we do return a variable type, and if it's yeah here. So and if it's a function, we return a type of function. So type would be, I think this returns qualified type. So we need to add this type here. So auto type function type. Let's get a function first. So also do. Oh no, we don't even need to. We don't have. We just need to. Like get or add add or get? I don't remember. Get or add type. Oh, it's in current check module. Okay, so we have current check module. Get or add type, which is type function type, which just takes a function ID, which we get from here, from the resolve identifier. So just something like that, and then qualified type will be type ID is func type, and this mode is false. We can't modify functions. So, like, then the assignment will fail if can't assign to read only. And it should even print a function type. So, and this whole thing can be removed. Can also make a unreachable statement so that the compiler wouldn't complain about missing return. And this will fail. Okay, here. Yeah, we are doing call type tracking, and then function ID would be function. No, it would be callable function. It's could actually get a better name, like function type or something like that. Yeah, it's function type. So okay, that should work already, I think. No, something in CodeGen. I haven't. Oh yeah, I need to type CodeGen a function type somehow, but we shouldn't ever get here. So function type. Let's have some placeholder here. So function, something like that, so that we see that we try to code again a function type, which cannot be done for now. Name. Oh, we can even use a name here. So back encodes and return nothing that return such. So no error. Okay, so let's check if our test for nested postfix works. So expected yeah, because we need to add something here. So this should file in like test is not declared, expression is not callable, not found operator for unknown, and then we have all these errors for these nested operators. But it's the signed audit parse, because we never enter type checking unless we have parsed the file successfully. So and then it printed out the entire expression saying that it's not callable. Yeah. That's nice. And also we should highlight only the name here. Let me fix that. Yeah, okay, I see. So name callable end would be the offset, and then we'll use just a callable end instead of the current offset. So Let's see. Oh yeah, the span is now correct. So we are only highlighting only the function name, and that's pretty nice. Okay, so let's also run tests, another tests to check if everything works, if we haven't broken anything. Okay. That would take a while because of C++ compiler being slow, and also I haven't parallelized that at all. But yeah. Okay. So it looks like it works, but let it run to the end. Okay, so we have 44 passed, but we also need to add expectation for these two tests. So nested postfix, which should error out. Nested postfix error. Yeah, we get this clunky thing because of escape sequences not being ignored. It will being still printed out even if we like even if we like pipe it to the file. So this, and also we have explicit not closed. So, but that is a separate comment. So first let's add this. So that would be allow functions to have arbitrary expression as callable. This implements basic, this adds basic function types which just refer to an existing function by its ID. Yeah. And also I added the wrong test. So out of order. No, that's nested postfix. Also add a test. Or like that's implied that we add tests in every comment. So yeah, something like that, and then let's add this explicit not closed error, like error case, explicit not closed ASL, explicit not closed ASL error. Okay, we get expected brace close, got E end of file. So that would be tests as test for unclosed expression list. I wasn't sure. I wasn't sure if it wouldn't crash. Yeah, so something like that, and then let's start implementing methods actually. So this thing should already parse, and it should fail on foobar as not callable or something like that. That would be tests, structs, methods, ASL. Okay, so it failed in expression is not callable. I think it's because no such field bar in struct foo. And now this should I think we can make methods just a special case for function which takes this struct as a first argument. Like these are methods anyway. Like functions that takes their struct as a first argument. So like the methods defined in the struct itself which take a self argument or this, like it doesn't matter that much. Let's be consistent with C++ in this and func like bar. And then let's take a argument like a number. Take and let's print it out. Wait. So like hello from bar. Something like that. And then this should fail to parse. Expected identifier with func. Yeah. But this should be basically equivalent to doing it like that. So this like from the type checker point of view. Like this would be like this won't be allowed by the syntax, but type checker would see methods like as global functions with a first argument being in this track. So let's use the well-known C++ syntax for defining methods. And do we start with parsing or type checking? Let's start with parsing. So so that would be parsed method, or we can reuse a code for parsing functions here. So we'll have for parsed struct declaration, we'll have fields and we'll have function declaration methods, which will have a which will have like this would be just a special case for parse parameter. I think like name would be this and type would be a method like a struct type here. So let's go to parse struct declaration and it will be now something like that. So field or method. And then if we start with func, so auto if peak type is func, we parse a function declaration, so we try to parse function declaration and then insert this as a method. So methods parse function declaration methods, and then we pass back a methods. And at the end we need to assign this to a struct declaration, which will fail because let's name it this. Parse struct the okay, that's the what the fuck, why is this needed thing. In C++, we need, like, it wouldn't allow me to move this into a vector somewhere here in the like somewhere here. because of C++ not knowing that this function is actually, like, this struct is actually movable. So we need to add this to the constructor, which is very annoying. But methods. So we add this as a field, and then no designation for us. Something like so. Okay. We have methods, and then yeah, like also we need to switch this thing. So this would be field, and this would be method. And type here. Okay. And then we'll parse. We need to parse this thing, which we can make it a keyword or a special name. A special name. Let's make it a keyword as all keywords for now, and if this will make problems, we can always change that. Like, also then it would be obvious that if someone uses this as a name, as an identifier, it refers to the, like, it's not some local variable that someone named this because that was his fantasy. So we have keyword this. Keyword this, which goes here. And then we need to lex it, so somewhere here we'll have this. Yeah. And then when we are like yeah, we need to parse this in the here when we parse parameters. So we expect identifier, but if it's not an identifier, so if we pick type is type keyword this, we just don't exit the type because it's implied by the use of keyword this. So like declaration parameters hash back parse. Like when we I think we can even make this into like bool is has this parameter thing, and why we aren't using designation here? I don't know. I don't really know. So let's use it. So tick, replace equals. Oh, so this would be false. This would be this string. Return type is unknown for now, so it would be empty. Parameters are default empty, and body is null for now. And name range. Why don't we have name range here? Oh, that was here. Name range is the last token, the range of the last token. So yeah, it has this parameter false, and then the first thing that we need here like just before this while. This while. Yeah, so we all expect a parent opens, and then if we get a this, we get it, expect a comma or not. If we consume a comma with a, so if peak or even, alright, or let's make it in another way. So let's make it here. So if peak type is this, we mark that we have found this parameter true, but we don't want to duplicate this. So if it already has a this parameter, we return a error that error in other direct. That would be we need to get this thing. So also this declaration already has a this parameter, something like that. And then otherwise, if that's not a this, we expect the identifier, party parameter, and a comma we get at the end. So the syntax would be roughly something like this, or name type and a comma at the end. Okay, so let's check if it should parse now. If I did everything correctly. Okay, so it compiles and it didn't parse. Okay, so I did something wrong. Here, expected identifier still, but got a comma. Do we even flex this? Yeah, we definitely likes this, because otherwise we wouldn't get a expected identifier. Like, how much places? 8 places there are, which expect variable declaration. That's strange. We definitely likes this properly. Oh, that's okay. And what are we doing here exactly? So okay, we expect a func, create a declaration while like we're expecting the initial identifier like this. Then we expect a parent. When we get a immediately a close, we get a close and go to the return type. And otherwise we okay, so we get a this, and then we don't get a comma, I think. It's we are just breaking, but no, but we aren't consuming this comma anywhere. So how was it done before? How did it even work? Did it even work? Let's see on the bigger screen. We are parsing a type and then just breaking like, multiple arguments shouldn't have worked at all, basically. So are there even tests for that? No, I don't see any tests. So let's add a test. So multiple parameters ASL. Foo, which will take a, or like just a basic add function. So a plus b. I think this should work. Why haven't I tested that? Tests, functions, multiple parameters. Yeah, that haven't. Let's even start this thing. And no, this haven't worked. This didn't work at all. So that would be a fix. So if next token is comma, we break, but otherwise we need to consume that comma. So and also add a output for multiple parameters. If that works. Doesn't work. I think it looks. No, it's just. It just took so long for some reason. A void function can return a value, yeah. That doesn't. That can be a void function, like. Okay, so. And then we run this thing, which should return a 20. Yeah. And then at the last step, we add a. Yeah. Add a output, which is 20. Okay, so. How do I even. Like I should add only this green part. So this would be something like only that part. And also let's check how it looks. Okay, so it looks nice. It looks no. There's something wrong here. Okay, a missing bracket. Let me see. So I need to add that line. So and unstage this. No. What am I doing here? Okay, let's just do it manually. Like tick. Let's check if that works. Okay. And that works. Yeah, okay, that works. So let's add this. The last. Okay, it's here. No, that's here. So if we go parser, actually fix parsing or make parsing of multiple parameters actually work. It wasn't consuming comma at any point. And add a test. Okay, then let's roll back this setup, and then this should work. And then let's go back to method. So, and test structs methods ASL. And this will fail in a no such field as before. But now we have this parameter working, which is nice. And then we should, if we even encounter a function in a method in a struct, we need to add it to the global scope, but with this parameter. And also we need to have this as a add as a argument here when type checking the function. So let's go to the type checker now, and that's the hardest part, I think. So going to parse struct declaration, and then okay, we are type checking fields, and then we'll methods, we'll type check methods, struct methods, and we need to type check a function, so type check function, and then we can immediately parse a body, I think. Function body. I think it's parsed. It's called only if we. Okay, it's called. It's called last, so we can just parse a signature here, and then if we parse a signature, this will return a checked function, and I think it would also add a function. Or no? Oh no, okay, I see. That's because I think parsing function, like IDs are added only here. That's we that is the type a function. Like the method expression, there's no field, bar is struct. Like, let's start with that. Like, no, ignore this thing, and let's go to the error. No such field in struct, yeah. But this can be also a method. So we, if that's not a field, what should have a bigger priority? Like, ideally we shouldn't be able to make duplicates. So, like, if it's not a method, we can assume that it's, if it exists, we can assume that it's a method. So, method. Then we can change this message to no such field or method in struct. So method would be struct find method. If method, we return an error without a proper range, and we return a we need to implement that for now. So find method with name. So we are iterating over all methods, I think. And if name is the same, we return, and otherwise a null option. Okay, so we add a method which what? Okay. I pressed, I think it's Ctrl M. Yeah. Accidentally. So we get a method which has a name and a function ID. Function and operator. What's this operator for? Okay, no. Okay, that's not added if it's not needed. Methods. And then we want to return a method here. So in methods with a name. So iterating over all methods, finding the one with a proper name, and then we get a qualified type should be function type. So we get a yeah. So it's definitely not mutable. You can say it already, but this would be a function type. So function type would be type. If function being method function. I think. Oh, that's because we use a reference wrapper. So we need to get, and then we can refer to the function ID, and then type ID would be current checked module get or add type ID of function type. Yeah, so type something like that, and then we can pass it here. Immutable and member access would be the object and a member, yeah. And that is obviously a function that takes a struct as the first argument, which we need to implement now. So now if we are type checking map struct, we need to also type check its methods. So struct methods, and then like the obvious thing we'll need to do is pass to the methods. So methods. That's the obvious thing. And name would be method name, and type would be no, that function would be some function ID. Like we need to get this function ID from somewhere, and that's the hardest part because like this makes functions like not matching its IDs, because currently we rely on the fact that functions are only declared on the global, in the global scope, but methods are not defined in the global scope. So this part is entirely wrong now. So we need to have some like mapping from the colors think we need to store function bodies somewhere. No. I think we can add a we can add for a module. We can add a or body program or module. With IDs are global, so oh, we have function to I. Okay, that's by the name. So so okay. So okay, so structs would be first here. Like they are type checked as the first. As the first thing. Like before functions, so the methods would be added first. But or we can even we can parse their bodies, but this would break recurrence. So can we can make parser as the functions to the global scope already, but then we wouldn't know what's the type of the first argument. That information will be lost. But we can. I'm thinking about a map. Like instead of this, we would use a map that would store all function or parsed function declarations and their mappings to the ID. It would have a function ID mapped to the parsed function. So, and that's I'm thinking where this should be placed. I think in the modules. So in the module, I think that's the best place because functions are local to him. Let's see if that works. And so we'll have a function parser, parse function declaration, parse declaration by ID. And then we return this from the internal map. So ID to parsed, also y binary expression, parsed function declaration. Something like that. Let's have this simple, and then This should be a vector actually, so John declaration. I need to parse function dec. The reference also we won't modify that, so we can return a const, and then we need to populate this list somewhere. So let's have a add parsed function declaration with ID and declaration. So mid to parse will insert this with ID and a declaration. And also we can make this const here because we won't modify this anywhere, and we are passing back actually. No, we need to insert. Yeah, that's because we don't know the order. This order can be arbitrary. Like, if we aren't sure, no, we should be sure that IDs are corresponding. That's the safest. The safe way is to do just this thing, and let's stay with that because safety is better than performance for the first pass. So this won't cost that much, but also find seconds. Let's assume that it exists here, but maybe it would be better to assert at least. So if it is mid to parse function and that's unreachable. That cannot happen, and then we return a declaration just like that. And also this expands to build unreachable, which doesn't need to fail like that. In this place I'm just informing the compiler that going here is undefined behavior, but that doesn't mean it will crash. Like, it can even ignore this check, basically. You say can be an assertion here. So let's have an assertion like it's equivalent. We are asserting that this declaration exists because it needs to be added before, like just when we are adding a function, we'll add it to the module. So add parse function declaration with function ID and a func. And the same we'll do for methods. So that will be here, which when we add a function ID, which is a add function. No, we current checked module add function, and then we need to add a parse function declaration, which is a method. What? Okay. We add this declaration, and then when we are type checking bodies, we can just easily get a module get parse function declaration by the ID, and that should work just out of the box. So And then let's check. Let's print it out for now. If if I did everything already. We aren't printing structs even, so we are printing functions. Let's see how this works. Basically, how does it work? So, okay, segmentation false. That's okay. We'll just debug it. Invariant. We get null pointer somewhere, but where? Resolve type here. So we have in frame 3 we have a this is okay, but type what? But type is a null pointer. Somewhere we are messing up this somewhere. So let's go to frame. So parameter looks like it's null pointer. Okay, no, it's somewhere higher. Where we are passing this even. Type check parameter, type check function, which is param, which is a function parameter. So this is the function is okay. Function is some garbage here. So I wonder. Aren't we move? We use. Wait. Let's. Well, no. Let's delete a move operator so that we can see where it's broken. Now this will fail here. Okay, we can't pass it. That's okay. That's okay. That's okay for now. But where we are changing the address, or are we even doing that? Okay, let's revert this thing and name. This is a complete garbage here. If we leave that, where we are get this function from? We are type checking. Whoa! We are getting function. So in frame 6 we are okay. So I haven't removed that. Okay, that's the thing that I talked about. So, that we are accessing. We are doing out of bound access here. So auto. We need to use this. This is okay. That there is a comment that use the fact that this is in parse function corresponding this is in checked function. That's no longer true because we introduced methods. So we are okay. That's the first pass. So we have all this all these parse function declarations in place, and then we can module we get so oh no, that's we parsed. We parsed module. We are getting a parse. Oh, we are getting a function. Oh no, we can't use current check module. We need to get the module properly. So mmodule and program get module or module that is just Yeah, which is a which has a get parse function declaration thingy, which could be even compressed in a single function on the program. So we could have like program get parse function declaration, but this is called in two places and like let's not make a mess in checked program. Okay, so now we are something is wrong with this, and oh, that's because I reverted the change. Too much changes I have reverted, so now we need to add it bypass. So that's okay. And then it should, I think it should compile, but let's check if it runs. Okay, so Pro has like it did some out, but still we still have no such field or method. So or methods. Let's print methods. Let's not print methods. Let's print structs first of all. So imports methods and functions for auto const. Method in methods. No methods. Structs. Struct. So we print all these structs. Do we have a print? No. So let's have that and a closing. Struct would be a name, and then we print no, we print fields. No. That will be field name and some type. That's name. Something like that, which function type name, or we have even type name. Oh yeah, we can use it here. Like this expands to the get type .name. Yeah, this is equivalent, but just for separate commit. Shouldn't conflict actually, so we can make it. We can even add it here. So let's commit this as the first, which so this will be check don't use type name in printing. Previously it was previously it was manual mining of that function there. No, there was oh, that's just let's just omit this description and go back to coding. So struct, we're printing fields, and in the same way we'll print methods. method has its name, so we do a func and some arguments which we'll ignore for now. Yeah. Let's see if this prints something. Okay, so we have no structs in prelude, but we have a single struct in here, but there's no fields or methods yet. Maybe that's because we don't even get to the... No, we should get to the type check struct thing. Oh, we are not passing methods here. Yeah, that's silly. Silly, but okay. So now we got it to type check. We get this method, and then it code can something, but this is totally wrong, and that's because we don't distinguish between. I actually don't know why. Oh, we are code getting it as a extern function here. Void bar. It has no body because it's not a function, it's a method. Like we are... It couldn't possibly work because it's a... Because we are never type checking method bodies. Like we are type checking normal functions here, but we never get to the structs. So yeah, we need to do also type checking of struct method bodies. But this should be... Why are we even using function to ID here? Can we use this this fancy parse function declaration things? Like we have all functions here. Get parsed. We have all functions, but we have only IDs here. Where you have... Where do you have all the functions? We should have these functions. Let's export this function array to get function. There's no such thing. Auto functions. Functions. Yeah. We have this. There's something called functions here. I don't see. Okay, it's here. So we don't iterate over function to ID, but just functions, and we don't even need to get this function now. So that's a optimization actually. And then we type check a function, so that's a reference, and get a function. And also we don't have a ID, but that's a counter, so that's a vector, so that's ID. So this is fixed by in C++23. You can do... I don't remember exactly, but that was... Like, there's a enumerate function basically in C++23 in this std ranges header. But for now, we need to do this awkward outside counter, or however, how it is named, however it's named. Well, okay, so this is something like that. Let's see if that works. Like, it wouldn't compile, but let's see if it code against this method. Oh, it's sec false. That's strange. But let's see where. We are type checking function body. Yeah, so we are probably type checking a method. So that's... But let's be sure. We are here. We are in... What is the checked function? It's null pointer. Okay, so again, like, that's why I don't have null pointers in my language. But the other reason maybe that I don't have pointers at all. So let's go back and print the func. So it's actually null. So it's so somewhere there is a null function added to the vector, and maybe like what is passing to this? Okay, we are passing here, and we are adding a null function. Yeah. So like I think I expect this to be filled somewhere. That's so yeah, we are adding a function, and then we are type checking them, and I think okay, I know that's because we expect the previous step to fill out our function, which we add here. So like we add here just the definitions, then we type check just the functions that are used. No, we are type checking just like prototypes or signatures. Yeah, just checking if this is the main function, if it has a proper return type and arguments, and like this is basically copying all these things, or yeah, checking if if we have valid types in parameters and so on, and adding a scope, which we need to do actually to add this type here, and it is accept this expression, but like this is the same fix basically. We need to copy we need here the previous step also to iterate over the all functions, not only the functions that have global name, which maybe it would be better if we renamed this field to like global function to ID or something like that, so that it's obvious that we are so that it works only for global functions. So we are getting a function, this would be function, another awkward counter here. Yep, func and the ID. Yeah, it's true. Module ID. No, like, what are we even doing here? Okay, I see. Okay, oh, that's the place where we are assigning a non-null. Like, not fully, but like type checked signature. It was not assigned previously. So here we need a module ID, which is, I don't know what it is. Is it even exposed? No, it isn't. I don't think it is. Okay, so let's expose the module ID here. Something like that, and module ID, and ID would be just ID. Call chosen constructed explicit. Yeah, fine. Yeah. Okay. And then this variable is under, so we can do a something like that. So this old school like increment, like helper variable iteration or index iteration, however. Like whatever it's named. Yeah. Less than funcs size id plus plus. Whoa. And then it's a bit cleaner. Okay, so this shouldn't crash. But let's see. Okay, so it did output something sensible, which is very nice. And it actually outputted a function here, so that's not a method, that's a global function as I expected. Because these are global functions, but just with a first argument being foo, which is not, which I haven't done yet here, but this should print something. So if we do build out, we should get hello from foobar 52. Yeah. So like the basic version of methods works, but currently these are just like static methods. Like they can't refer to the inside field of these structs. So let's have a field, a numeric field, and print like something like that. It would be a equals, so a argument and field equals a field which we refer by this dot field, like in most other languages, and this won't build. No. Yeah, because we get this, but we expect an expression which to that thing. Okay, maybe let's let's commit that thing for now. So so this, and also let's like this is just a framework for methods basically. So, or maybe not. Okay, maybe let's leave it for the later. Like, let's make a single commit for all the methods, because like that's the first part which doesn't work at all. Like it does follows the method syntax, but this doesn't differ from the from this isn't in methods yet. So so let's go back to the parser, and when we are parsing a primary expression, we expect this keyword. So if token type is this, we get it, and let's just make it a identifier. It doesn't differ from a it doesn't differ from a field, from a normal field. So like it's just an identifier with a type of the given method of the object type, and as I said multiple times in this video. Let's not repeat. So this should fail in the type checker. Or no? Yeah. Okay, so this is not declared. Yeah. This is not declared because we haven't declared it anywhere. And that when we are type checking type check function, yeah, when we are type checking function, we need to take that into account. As we need to add it as a parameter. That the function has this argument, that is this parameter. So if function has this parameter, we need to add this as add a also what's going on here. What is this? Why don't I get a error about unused variable? Okay, maybe I need to enable this error. So we okay, I know. I think I know why that's why didn't they get here. That's because like C++ requires if there is a non-trivial constructor, it can have some side effects, and like this would make some like RAII classes like this scope guard. Compiler would complain about this being unused, even if it is like crucial for making this type checker work. So that's why I don't get a unused warning. So we have a name which is this, and we type check. Do we even type check this parameter? No, we are passing. We can make this a separate function so that we won't clobber the type check function. So we type check this parameter, and then we should get a current struct from somewhere. So we want to resolve the type. We have a scope. And that's the place where we complain about methods not being in structs. So, insert. We insert this, and also where we are getting this byte from. Okay, it's here. So name would be this, and type would be like current struct type, like something like that. Like let's have a placeholder. So, yeah. Okay. Let's have this as a let's have a declaration type checker, And then here we'll just call this type check this parameter thing and a chemical, which is cannot convert. Okay, yeah, because that's explicit. That constructor is explicit, yeah, which is very weird. I think I did it deliberately. This explicit. No, it's no. Okay, that's strange. Oh, I think that's this constructor which should which should be used here, but okay, never mind. So, and also that's something is suspicious here. Oh, okay, that's fine. We are decoding this thing. Yeah. Okay, so yeah. So we are adding this parameter, but we need to know what is the type of the current. Let's have a null struct and see where it's called from. I think that's type ID. Let's have, I don't remember, and that would be the easiest way to find out. So we compile this and okay, run. I didn't have a breakpoint. So new breaking type checker. 455, I think, or at the beginning actually, and yeah. So type check module get function, yeah. So that's the first pass. That's the first pass. So we don't know what's the method here, because so maybe we need to that's okay. Need to check function. We are type checking function. Like we okay, let's go to type check rack and see what happens here. So we add a function, and then the only information that we have about the method is in the struct itself, but the function doesn't know that it is a method. It knows that it has this parameter because the parsed function has this parameter, but that could be changed. I think we could make this. You could make it obvious at the parser level. No. We could we could iterate over all of structs and over all methods of this struct. So like and just search for the method that we add here, which doesn't do anything currently because we are not accessing this field anywhere. This method list we are, or are we? No, we are checking. We are checking in the member declaration, but that's all we do. We need to have some information about this, about the function is a method. So like we add only the ID, so like we inform the type checker that the function exists and that it corresponds to this AST node, like this parse function declaration, and that's the only thing we know. And also we add it as a method so that it can be referred to in method expressions, in member expressions. It's not an easy problem, I think. Reality function. Model functions so that they can be referenced. Add function and so that they can be referenced like in this means that they can be not referenced, but it can be like referred, found by name, like basically resolved. This doesn't check any arguments, any parameters, return value here. Basically, that's what the third step does. Only adds them to a map of function by name. But that's and we are doing this also here, but we are definitely adding this function as a global function. And I think the easiest solution would be to just add this information in the parser. Like the parser knows that it parses a method, so it doesn't know, but it's trivial to do to make that it knows that it parses a method, and then instead of having this parameter, we'll just add a parse parameter this. So that would be like syntax sugar, basically. Over that would be almost equivalent to doing this outside then. So for doing like this, except that wouldn't compile and this couldn't be referred by the dot operator, like member access, but otherwise from the type checker view point of view it would be equivalent. So let's do this in the parser way, and instead of having let's not have this, have a parser know that the struct or the struct name it is currently parsing. So the parsed struct name, and at the end this is used for methods, you know that they are methods in a given struct. Yeah. And then if we parse a if we parse struct declaration, we get a name, and then we can temporarily change this name, this currently parsed struct name, to the name, and also and the code, yeah, right. Optional using. Whoa. I think this returns a reference. But wouldn't that be a undefined? I don't remember. Okay, let's see if that would work. Okay, so we set a currently parsed struct name, and then we could also pass it here as an argument, but maybe that would be even cleaner. But what we if we have like nest this is a hack obviously, and this wouldn't work for like this wouldn't work for nested structs or namespaces or things like that, but it's okay for the first iteration. Like it's okay for the first like working version. So we won't do this, and then if we have a this parameter, okay, so we store this outside. So as this parameter is false, and if we have parse this, and now we need to add a parse parameter with type being the parsed type is equal to type is equal to parsed to struct type. No, yeah, no, don't remember again. Type, that's unqualified type. To parse unqualified type of name is equal current struct, currently parsed struct name, and then that's another line. Name is this. Name is this of that parameter. And type is a struct name, currently parsed struct name. And also that's the place where we should let's add this missing comma, and that's the place where we should check if pass other if declaration parameters is empty, we need to check if this parameter is first. So error already read would be range. Let's have a empty range. Because what is the range for this parameter? What is the type range for this parameter? There's no range, so we can use a empty. So this declaration has already asked this, or that will be this parameter must be the first. or this must be the first parameter. Yeah, that's it. And then we have a error here. That's about this parameter, and we can remove the special case, and also we can remove a type. Check this thingy. And that should that will fail because that will fail at C++ stage. That's my guess. No. Can't convert U32 to full for function argument. Yeah. So this does work as a. And now we need to pass it as a value here, the first argument, and it will code again as yes, it will code again the wrong way here, because this is a keyword, and then we have this as a I think this is a pointer also, so we need to use this as a pointer. I guess doesn't matter for now, but when I will thinking about the ownership model, this will be important. Right. Okay. So we have a basic version. Then we need to make this. We need to make this code again properly, and also pass the first argument as object argument. So in the type checker, when we do a member call, if we call a member, that's because I am even doing this right. I don't think I'm doing this right. Like, can't even distinguish between. Like if I get a let's see, if I have this expression, it returns the function as a normal global function. When we are parsing this call, this call operator, we can't even know that the method is but this is a method. We can't know that we need to pass this foo thing. And let's actually do something like foo bar bus, something like that. And what should it do? So we have a tree which is foo. Like this thing. No, we have this. This is called. So call this thing. And this is a member of bus. So member and field object is foobar, which is called. Also, no, there are no args here. Okay, so we call a foobar with 41, and then that's a member with object foo and member bar. So this is a AST, so abstract syntax tree. But then we turn it into a type checker tree. This type check tree with all the types and so on. Then it's identifier foo. And then what we are doing, we type check the call. So that's a type checked tree. Here we are. A call which calls a member, which calls, and then we have all the types. So this is type foo, and then this call knows that it calls a member, so it knows that it calls a member. So if it calls a member, we know that we need to pass the first argument. Like the member is member is not a type of function. Member is some kind of function. It's function bar. It's function bar. Yeah, which is a function that takes this and a. So yeah, I think we can do this. So we are first call. When we are getting a function, yeah, but the first argument, like if we are calling a method, so if callable, if false alternative, member access. So it's a member access. No, expression. So it's a callable member access. We want to pass and also ball, something like that, and like print would be it's a global, so we want to have method called to be false, and if if that's a method call, we want to add this as a first argument. So we add a this the first part, the object argument we add as a first argument. So arguments, we need to pass back a callable, so cd get checked expression member access of expression object. Yeah, and that would complain about the copy. We can move. Can we move this thing? Is it even used anywhere? Like, no, it is used. It is used in the CodeGen. We need to copy this somehow. The first argument also this. No matching function for constructor. Implicitly the copy constructor, yeah. That's because we have multiple unique pointers here, and we can do first, see, we can do something like a plus b dot something, and then we need to know this for the no. We don't need that for method calls. This first call will just have a first argument, which will move, and then a callable will become callable, which we return here somewhere. Oh, we don't even need this callable. Okay, I'm confused now. So we have a call with function. Okay, we are just knowing that we call a function without knowing that it's a method. Like functions are entirely global. We don't even do anything with this collab. We just check. Like it's if I see correctly, it's not even used anywhere after this move. So yeah, we can safely move. You can safely move this object out from the callable and use it as a first argument to make the CodeGen working. Well, okay, so now this failed because I can't convert U30 to the full function argument. Oh, it's because it's because we are just because these parameters are, I think, so if it's method call, we need to increment this because in the first expected argument parameter or argument type is an object, so we need skip it, add it here and skip in the loop below, something like that. This failed as invalid memory access on non-struct type void. Yeah, I haven't. Also, valid member access, so that would be a span, or that should be a span. That should be a span. And expression not scalable, yeah, because it's have only that. Fails. No invalid arguments expected before this, and yeah, invalid use of this, blah blah blah. Then we just need in CodeGen we just need to replace identifier with the so if var name is this, we need to suffix it with something. And the same for expression. For identifier, result identifier. And that's for variable. So like name is something like that, and this would fail because of C++ being weird. Or no, maybe that's something like that. And the same escape thing or escape hack. Yeah. So that compiles, and we have hello from foobar a is equal 42, field is equal to 0 because we haven't what? Because we haven't set this field to anything. And let's set it to like 2137. That's a funny number. Yeah, so this basic thing works. But I think it's easy to mess up with that. I think if I remove this, okay, it will invite member on nonce. This is not declared, yeah. Invite member access of non-struct type unknown. Okay, too many arguments to call to bar, and that's we should make this error better later. Also, if I define it outside, it will what it will do? It will crash because of Badalog. Okay. I think that's expected because I haven't done anything about checking for this. Parse function declaration, yeah, we don't even check that. So if there is no currently parsed track name, we also what? If we are not in function, also let's do this first. Return error in already read. This declaration maybe a parameter only for methods. Something like that. This error message could be better, I think. That's only the wording. Okay, so this parameter may be only for functions, and that's a separate test. So merge method outside struct, and remove this and this, and this should be enough. And this test method outside struct should fail with this maybe a parameter only for methods. Other expectation, a set error, and then we have this maybe a parameter only for methods. So, and also the method thing would be something like that. So this, oh well, wait, error would be empty. Or no? Did I broke something? Yeah, I did broke something. So this doesn't work. That's it. Let's use a let's do something like that. Like it's another hack here, but if it works, it's okay. We can even add a fix me to fix that in a temporary change. So make temporary change. Also it compiles. Yeah, nice. Change work with anything that is assignable to the variable. Maybe. I'm not sure if that's a correct solution to that problem, so let's add a maybe, like that we don't imply anything. Okay, so how it works. Hello from Fubar is 52 and field is to 2137. Nice. Okay, so now let's let's add a expectation for the methods test. No, actually. So we build out tests, structs, methods, ASL out. And this is wrong. So we can run all tests. Run tests to spy and check if I haven't broke something. And in the meanwhile, let's write a commit message for that. So this would be the test, and oh yeah, no existing field. Another error. Expected success, but got compiler error. That's why we expect success here. Non-existent field. No, we don't expect. We shouldn't expect success here. It's an error. It's an obvious error. Maybe that's. Let's see what does it. How does it work? Tests. So it prints no such map. Oh yeah, that's the error message changed, but there is such a weird way to say that from the test run. No such field or method. And then it should work. So should add a test for non-existent methods, I think. Let's face again. Let's do it the proper way. We could, I think we could trim this white space so that we don't need to bother about this trailing new line when checking. Okay, so no such a filler method. Yeah. Then we can run tests also. And implement basic version methods. Also, oh no, we can't commit it because methods aren't mangled in any way. So we end up with too many clashes here, and that's for another test actually. code again. I mean that because we are printing. Okay, all passes. That's nice. But let's add another test which should fail. No, which shouldn't fail. Method, the same name as function, and we have a function foo which does nothing and extract foo with a method. Like something like that. This shouldn't print anything, but also shouldn't fail. So let's print awk. Let's print awk. And then currently it will fail because, or no, it wouldn't fail. It would fail only if we do this, something like that. And then it would fail, but I'm not sure if that's so bad. Like, let's just see if how does it work. Like, so test extract expected, yeah. Seriously, I forgot to yeah, that's a declaration. So this will fail because of redefinition. Yeah, that's a thing for later. Let's just add this as a fix me. Code again, function declaration, and fix me handle mangling of methods so that they don't clash with global functions. This, yeah, something like that. And then these uses methods are now just special global functions which their argument as the first argument. This version also uses a hack in parser which wouldn't allow, which doesn't allow to nested structs, but that's okay for now because we don't have nested functions, nested structs. And a smiley face. Yeah. So Outgun, so the yeah, so I think that's everything. So let's run tests again to be sure if they work and if it works, and if so, we can end the video, I think. Okay, so 3 seconds. That's slower than always. So something is wrong. I think it's maybe because of recording, but these tests are really slow now. Like 5 seconds for some precedence thing. That's so bad. Like That was like 2 seconds or 1 point something, and there's like 8 seconds now for some tests. It's I really should parallelize that at some point. Okay. Let's just feel the silence. 7 seconds for imports. And that's not even a... Also, why are these problems jumping? Like, oh, okay, but 126.7 for the entire test suite, but all passes, so that's nice. Also, this is the end of the video. If you liked it, you can do something. I don't mind really. Okay, bye.